Alcan, the international aluminum company. One enterprise with many faces. The company has always been international from its beginnings. Aluminum is by its very nature a global business. More than 70,000 people in over 30 countries work for Alcan. Mining ore, smelting the raw material into aluminum, making it into so many familiar products and supplying them to customers around the world. And its employees around the world reflect that international scope. The company employs nationals to do the job. Latin America, Africa, Australia, Europe, Asia, North America. In many countries, you will find the plants, the laboratories, the sales offices. These are the national faces of Alcan. But where does it come together? It all starts with Alcan's philosophy. All its employees have heard the message. It describes where the company is going and how it behaves. A common language in many tongues. Excellence in performance, one enterprise serving many communities. The action on the Alcan playing fields speaks volumes about the real teamwork that exists throughout the company. Alcan does more than just create work in so many countries around the world. There's also a sense of community that goes beyond the workday. The production of aluminum starts with bauxite, mined in South America, Africa, Australia, as well as here in Jamaica. But the company doesn't just take the raw ore and ship it from the mine. Alcan workers process the bauxite into alumina, the first step on the road to aluminum. Next, the alumina is converted into aluminum ingot. From here, it's rolled or extruded into the many familiar shapes that are aluminum products. But getting to the finished product is a complex job. The movement of the basic raw materials is such a massive task that Alcan has ships plying the oceans and rivers of the world, from the Amazon to the St. Lawrence, from West Africa to Ireland, from Australia to British Columbia. The Alcan world, the trade network that spans the globe, is vital to the company, bringing together materials, people, and technology. Bauxite found mostly in the tropics, refined to alumina, transformed to aluminum in Alcan's many smelters. Then on to the manufacturing plants in the major industrialized countries and, increasingly, in other parts of the world, such as the growing markets of Latin America and Asia. Alcan is a worldwide company, relying on the people around the globe who work for the company from Quebec to Kuala Lumpur, from Auckland to Oswego. Canada is Alcan's home base, a country with vast natural resources, especially one that is key to aluminum, electricity. And in Canada, Alcan has a reliable supply of hydroelectricity. It has recently expanded its aluminum smelting operations to include this most modern facility at Grand Bay in Canada. Aluminum produced with economical electricity in one of the most technologically advanced smelters in the world, produced by a skilled workforce whose fathers and grandfathers also made aluminum. And as elsewhere in the Alcan world, there's a sense of community and cooperation. Alcan and aluminum also team up to solve customers' problems, for the company does more than just make aluminum. At the plants which turn out aluminum products, technicians work on solutions, such as this new packaging material here in Switzerland. Other Alcan people are out talking to customers, helping meet their own individual needs with aluminum. This research center at Banbury in England is one of the research facilities located in Europe, Asia, and North America. Alcan is developing the kind of innovation needed to come up with new aluminum products and better ways to make those products. One example is this computer-controlled plasma cutter. The aluminum is cut to size with greater ease and precision. And innovation is not always some dramatic new production tool. Perhaps it's a product you see every day, such as a new energy-efficient aluminum window, this one made at an Alcan plant in the United States to keep the cold out in the northern winter. Aluminum cans are a light, clean solution to a packaging problem. This can line at an Alcan research center uses the same equipment as the manufacturer, so Alcan can fine-tune the product to meet customer needs. These cans can be economically recycled. As a matter of fact, recycling uses only 5% of the energy needed to make the metal in the first place. In the fields of energy conservation and recycling, aluminum is hard to beat. Sometimes, aluminum can provide a basic solution. Here in northern Africa, Alcan is working to solve an age-old problem, getting water to irrigate crops in an arid land. Aluminum's light weight makes it easy to carry and install these pipelines in remote areas. Portable irrigation means that vast areas of the desert and near desert can be watered, producing crops in once barren land. Aluminum is the natural ally of motion. And transportation is a natural market. Alcan is a qualified supplier to the United States space program. Specially prepared aluminum powder made by Alcan powers the rockets. Light, strong aluminum is tailor-made for the space shuttle, that highest bit of high technology. The tanks which hold the fuel are made of an aluminum alloy, and so is the skin of the shuttle itself. While drifting in space, the astronauts are protected by aluminum-coated spacesuits. And part of the shuttle's job in space is to put aluminum-covered satellites into orbit. Closer to Earth, Alcan reaches out to solve special problems for customers, and this train called the LRC for light, rapid, and comfortable, is one example. Alcan engineers were involved not just in the light metal for the body, but in many aspects of the design, including the unique suspension system, so the LRC can run and corner faster on ordinary track. This aluminum ferry is called the Seabus. On its daily commuter runs in the Vancouver Harbor, it takes people to and from work. Alcan aluminum is used here because its lighter weight means the ferry can carry more and use about 15% less fuel. In the same waters sail these aluminum fishing boats. Like the Seabus, these aluminum vessels resist corrosion. Aluminum above and below the waterline means that the trawlers and seiners can stay unpainted, saving the fishermen time and money in maintenance costs. In recent years, aluminum has seen increasing use in cars as manufacturers work to lighten the load and save fuel. Substituting aluminum, as in this aluminum car bumper, is one way. These Alcan workers in Canada are extruding aluminum for use in a European car to be assembled in the United States and sold throughout North America. In the world of aluminum, all the pieces of the puzzle come from all over the globe. And at no company is that more true than at Alcan. And in the car of the future, aluminum will be used even more, replacing heavier materials and saving energy. Out of the car and into the kitchen. Alcan aluminum foil to keep the juices in a good cut of meat or the freshness in a sandwich lunch. Clean and modern, an everyday use of aluminum we take for granted. If some uses of aluminum make the world a little more efficient, some others make it a little more beautiful. Such as this modern church in Germany, structured out of aluminum, from the steeple to the ground. Such is the diversity of aluminum. Once as precious as gold, development through research and technology has made it an everyday metal. Aluminum technology, which was developed by Alcan and others. New technology, which will continue to develop for everyone's benefit. Here in China, the company's Japanese affiliate built a new smelter in Guiyang province, in the southeastern part of the country. This is the latest technology, a pre-bake smelter. It was built in Japan and moved to China. The technology was developed jointly with Alcan, and the company's employees from Japan taught the new technique to their Chinese customers. This 80,000-ton smelter is an example of how Alcan, its subsidiaries, and partner companies transfer technological know-how around the world. At the company's aluminum sheet plants all over the globe, the metal can be seen in the form of these big ingots, which can be rolled into thick plate or thin embossed sheet. Whether it's for the skin of an aircraft or to cover the skin of a turkey, aluminum can be specialized by adding different metals to produce alloys of aluminum. A small amount of magnesium, and you have the alloy of which aluminum cans are made. A measure of zinc, copper, magnesium, and lithium, and the resulting alloy can handle the temperature and stress of modern aircraft design. While it sounds simple, the production of aluminum alloys is precise work. At Alcan Labs, chemical, electrical, and ultrasonic testing all form part of the production process of high-strength alloys. And the future holds more promise. Alcan is involved in long-term research into other uses of aluminum, such as the aluminum air fuel cell, seen here at the company's research facilities in Kingston, Canada. The battery uses just air, water, and aluminum to produce electricity. Pull out the aluminum, and off goes the television set. In another form, the aluminum and salt water combine to spin a propeller. The aluminum air fuel cell could, in the future, be an alternative power source for buoys in the ocean or cars in the city. Technology such as this could affect the daily lives of people around the world in the years ahead. Alcan companies share technology with each other. New ideas and techniques developed in one location travel on the information network of the Alcan world. Knowledge is put to work wherever it is needed. At Alcan, there's a way of doing things that people recognize and value. It's a human touch, person to person. For in the end, the quality of the company is built upon its people. People with different backgrounds, but a common purpose, sharing resources, technology, and values that together make up the Alcan world.
$150 years ago, aluminum was unknown. Today, it is fabricated to provide many of the conveniences of everyday life. Man has learned to produce aluminum in large quantities and to take advantage of its versatility. In fact, aluminum has become one of the most widely used metals. The aviation industry was among the first to adopt it. 3 times lighter than steel, aluminum gained its popularity when it was discovered that by mixing it with small quantities of other metals, its strength and formability were improved. Aluminum is a good conductor of heat and electricity and is widely used in the making of wire and cable. Aluminum's corrosion resistance, as well as the ease with which it can be fabricated, make it an important material in the construction and packaging industry. No other metal is as easily shaped by man. It can be rolled, forged, cast, and extruded into a variety of shapes to make just about anything. No wonder, then, that aluminum has become the most widely used non-ferrous metal. Aluminum is the 3rd most abundant element on Earth, after oxygen and silicon. But it was not until 1825 that it was isolated by Hans Ørsted, a Danish physicist. It remained undiscovered for so long because it does not exist in pure form. It is always combined with other elements and is most often found in the form of oxide. Aluminum oxide, or alumina, is found in many minerals, but bauxite is the ore most commonly used in the making of aluminum. It is difficult to imagine that this red, shapeless earth conceals such a brilliant metal, and yet bauxite may contain as much as 30% aluminum. Bauxite appears in rock or soil form. Its color, which depends on its mineral composition, is white when silica content is high and red when iron content is high. Bauxite is found predominantly in tropical latitudes where it is mined from large open pits. The major bauxite-producing countries are Australia, Jamaica, Brazil, and Equatorial Africa. Bauxite undergoes a long chemical process before its aluminum is liberated, aluminum it may have been holding for millions of years. The first step in producing aluminum is to separate the alumina from the other compounds contained in the bauxite. First, the bauxite is ground and mixed with a solution of hot caustic soda in digesters under pressure. The caustic soda dissolves the alumina while leaving the impurities in a solid state. The solution is then filtered in order to remove these impurities and passed through a precipitator. Here, crystals of alumina trihydrate take form. These crystals are separated from the solution, washed, and then dehydrated in kilns. The temperature in these kilns may exceed 1,000 degrees. The resulting white powder is called calcined alumina. The alumina is now transported to an aluminum smelter, where it is reduced into aluminum. Aluminum smelters are sometimes thousands of kilometers from the nearest bauxite mine, in which case they must have good means of access to the required raw materials. At the smelter, alumina is fed into an electrolytic cell or pot in which a strong electric current breaks the solid bonds between oxygen and aluminum. The electric current is fed through the anode, made of carbon. The anode burns away in the course of the process and must be replaced from time to time. Inside the pot, the alumina dissolves in a molten salt. The electric current breaks up the aluminum and the oxygen. The oxygen rises to the surface and reacts with the anode carbon, while the aluminum is deposited at the bottom of the pot, at the cathode. Periodically, the molten aluminum is siphoned into a large mobile container known as a crucible. Once alloying is completed, the molten aluminum is poured into a variety of ingot shapes. The electrolytic process was discovered a century ago and has been improved over the years. Today, research continues in order to find more energy-efficient ways of producing aluminum. Electricity, most economically generated by the renewable resource provided by falling water, is a key factor in producing aluminum. This is why smelters are often located either near an abundant supply of hydroelectric power or other energy sources. To produce 1 kilogram of aluminum requires about 15 kilowatt hours of electricity. For this reason, economic power sources influence the location of aluminum smelters. It is because of hydroelectricity that Canada has become one of the world's principal aluminum producers. Canada, the #1 aluminum exporter, accounts for about 1/15 of total world aluminum production, which reached 16 million tons in 1980. World demand for aluminum is anticipated to increase by an average of 4% yearly. To meet this growing need for the metal, companies must increase their production capacities. Canada, in the 80s, will see the construction of several new aluminum smelters, such as Grand Bay. This plant, which Alcan has built at a cost of about $500 million, uses the latest technology, with special emphasis on energy conservation, good working conditions, and protection of the environment. The age of aluminum has just begun, and the demand for aluminum is growing. The dawn of this new age brings new applications, new and better ways of using aluminum that are constantly being developed. Large amounts of electricity are needed for making aluminum, but aluminum in return allows for energy savings due to its light weight. This characteristic has opened new and important horizons for the metal, particularly in the field of transportation. With the development of the LRC train, aluminum is contributing to putting mass transportation on the right track. Aluminum use is also increasing in the automobile industry, where, again, due to its light weight, it contributes to fuel savings. Aluminum has another important asset. It can easily be recycled, using only 5% of the energy required for its original smelting. New needs and the ever-increasing importance of energy conservation could result in the age of aluminum continuing in an uninterrupted cycle for years to come.